Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam and other exams related to physical science. Okay, so guys, this is the lecture number 6th of the optics, in which I'm going to discuss gate PYQs. Okay, optics gate PYQs. Okay, so I'm going to start. The question number first is, question number first is a point charge, a point charge, a point charge is placed between two semi-infinite conducting plates, two semi-infinite conducting plates which are inclined which are inclined at an angle 30 at an angle 30 degree with respect to each other. Okay, each other. The number of image very good question guys. Okay, the number of image observed is, okay. So this is the question guys. A point charge is placed between two semi-infinite conducting plates, okay, and which are inclined at angle 30 degree with respect to each other. Okay, the number of image observed is, you need to find out. Okay, so I'm going to solve it. So suppose these are two semi-infinite conducting plates. Okay, so one is this and one is this. Okay, so this is infinite and this is also infinite, semi-infinite. Okay, and at these are at angle 30. Okay, these are conducting plates. Okay, conducting plates and semi-infinite conducting plates. Okay, these are semi-infinite conducting plate and the angle is 30 degree, that is theta, right? That is given, that is 30 we have been given. Okay, so we have to find number of image observed. How many images we are going to observe? Okay, so there is a formula guys, you need to note down, very important formula. So number of image is 360 upon theta minus 1. Okay, very important formula, note down and memorize it guys. Okay, practice questions using this formula. So then these formulas are going to be in your fingertips. Okay, so n equal to 360 upon theta minus 1. So value of n is going to be 360 upon 30 minus 1. So 0 0 will get cancelled, so this is going to get cancelled by 12 minus 1. So value of n is going to be 11. So the number of image, the total number of images, right, number of images are going to be 11. Okay, the gate question guys. Okay, so done, this is done. Next question. So you need to note down this formula guys. Okay, so for finding the number of images. Next question guys. Next question is, a beam of X-ray. This is a numerical type question guys. Okay, in gate. So this is a beam of a beam of X-rays, of intensity beam of X-rays of intensity I naught is incident normally on a metal sheet of thickness 2 mm, okay, 2 millimeter. The intensity of the transmitted intensity of the transmitted beam is 0.025 I naught. Okay, the linear absorption coefficient the linear absorption coefficient of the metal sheet in meter in metal sheet in per meter, okay, in unit per meter is, okay, you need to find out up to gate question, guys, okay, up to 1 decimal place. Okay, so a beam of X-ray of intensity I naught is incident normally on a metal sheet of thickness 2 millimeter. The intensity of the transmitted beam is this 0.025 I naught. The linear absorption coefficient of the metal sheet in per meter is, you need to find out. Okay, very good question. So this is the metal sheet. Okay, this is the light of I naught incident on this metal sheet. Okay, and then the transmitted light intensity is 0.025 I naught. This is given. Okay, this one, and the width of this is given 2 mm, right? So now we have to find out absorption coefficient. Okay, so we have a formula for that, guys. You need to note down. I equal to I naught e to the power minus mu x. Okay, I equal to I naught e to the power minus mu x. You need to note down and solve questions using this formulas. Okay, so I equal to I naught e to the power minus mu x. Mu is the that linear absorption coefficient. Okay, and x is the this one x is the width of the sheet. Okay, thickness of the sheet. So we'll put the value, simple. So this is going to be I is given, right? I is 0. This one transmitted light 0.025 I naught is going to be equal to I naught e to the power minus 2 mm, right? So this is minus 2 mu x, 2 mu, right? Minus 2 mu. So we have to find linear absorption coefficient. Okay, so minus 2 mu So this is the formula, guys. I equal to I naught e to the power minus mu x. X is the that one, the width, thickness, right? So from here, this is going to be I naught will get cancelled, okay, and e to the power minus 2 mu is going to be 0.025, okay. Okay, so from here, now we'll take log in both sides, okay. So this is going to be minus 2 mu equal to this is log 0.025, right? So now from here 2 mu is going to be, this value is minus, if it will get this value, okay. This is 3.688, minus minus will get cancelled, okay. So value of, so this implies value of mu is going to be 3.688 upon 2, and this value is going to be 1.844, okay. This is the answer. This is the linear absorption coefficient, guys, okay. So very good question. Next question, guys. Meanwhile, just let me check whether I'm audible or not. This is important thing for me. Okay. Sixth of yes, I'm audible, so I'll proceed further. Next question, guys, okay. This is very important question, guys, and conceptual based question, and I'm going to solve it for you. Question number 3 is, question number 3 is a beam, this is a plane electromagnetic, a plane electromagnetic wave, okay, EMW, that is electric field is given, okay. So this is equation is given, x plus Iy E naught exponential of iota kz minus omega t, okay. Plane wave, a plane electromagnetic wave, okay. The wave equation is given, wave after passing through, after passing through an optical element, an optical element emerges, okay, emerges as, so this is this passes through the optical element, okay, emerges as x minus iota y E naught exponential iota kz minus omega t, okay. Kz minus omega t, where k and omega are the wave vector, are the wave vector and angular frequency, and angular frequency, angular frequency respectively. Angular frequency respectively. The optical element is a option A, quarter wave plate, option B is half wave plate, option C is polarizer, and option D is Faraday rotator. Okay, Faraday rotator. Okay, so this is the question. A plane electromagnetic wave, this is given, after passing through an optical element emerges as this electromagnetic wave. Question becomes like this. Okay, so where k and omega are wave vector and angular frequency respectively, the optical element is, what is optical element? Is it a quarter wave plate? Is it half wave plate? Is it polarizer, or is it Faraday rotator? Okay, that we need to find out. Well, so here I'll tell you some points, then it will be clear. Okay, so retardation plate. First, you need to understand about retardation plate. Okay, retardation plate. Okay, this is a plate made up of a a doubly refracting crystal, which creates a particular path phase, path or phase difference between E ray, that is extraordinary ray. I have already explained what is extraordinary ray and what is ordinary ray, E ray and O ray. Okay, so retardation plate is a plate made up of a doubly refracting crystal, which is made up of a doubly reflecting crystal. Okay, which creates a particular path or phase difference, between the E ray and O ray. That is extraordinary ray and ordinary ray. Okay, so that is called retardation plate. Okay, so here the delta value is going to be n naught minus ne into d. Okay, where n naught is constant of ordinary wave, and ne equal to constant of extraordinary wave. Okay, very important point, guys. You need to note down it. Okay, so then you will be able to solve the question which you have got at the moment. Okay, n naught. So where n naught is uh, constant of extraordinary ray, constant of extraordinary ray. Okay, that is constant of extraordinary ray, Ne. Okay, Ne. And NO is constant of ordinary ray. I'm going to write in short. Okay, so it's ordinary ray, O ray. Okay, this one. So from here, and also the delta value is going to be 2 pi by lambda, because we know 2 pi by lambda, and this is the phase difference is 2 pi by lambda into part difference, that is n naught minus ne, n naught minus ne d. Okay, so this is the part difference for retardation plate. Okay, so retardation plates are quarter wave plate and half wave plate. Okay, these are quarter wave plate, quarter wave plate, quarter wave plate, and half wave plate, half wave plate. Okay, so for quarter wave plate, you need to know that delta value is pi by 2. Okay, for quarter wave plate, delta value is pi by 2, and this delta this. Okay, and the phase difference and the part difference value is lambda by 4. This is for quarter wave plate. For half wave plate, the value of delta, the phase difference is pi, and part difference is lambda by 2. Okay, half wave means phase difference should be pi, and part difference should be lambda by 2. Quarter wave plate means phase difference should be pi by 2, and part difference should be lambda by 4. Okay, so this is the one, guys. Okay, this one. So for that we can also get the distance as well. Okay, I will show you like this. Okay, so this you need to note down at the moment. Okay, this is important. Now we'll solve question. Okay, in question we have been given EI is given, initial wavelength is given. Okay, so that is E naught x plus IY e to the power iota kz minus omega t, that is given right in the equation, this one. And after passing through optical element, the wave is going to be ER. The ER is after reflection, or that is after passing through this one, refraction, after refraction. Okay, this is diffraction. ER is this is given E naught x minus iota y e to the power minus kz minus omega. Okay, so ER and EI are this. Well, so this is important. These are retardation plates, are this quarter wave plates and half wave plates. Okay, definition I have already explained. And here, so these are the condition for quarter wave. For being quarter wave plate, part difference should be lambda by 4, and phase difference should be pi by 2. For half wave plate, path difference should be lambda by 2, and phase difference should be pi. Okay, so now from here we can get we can get, you can see here, this is the equation, right? So from here we know that is, just wait guys. So this we can write like this. Okay, so ER we can write like this, E naught x plus e to the power pi iota y e to the power iota kz minus omega t. We can write it, right? Because minus 1 value is e to the power pi value, since we know e to the power pi equal to minus 1. So in place of minus 1 we have write this. So it means phase difference is, for two wave plates, the phase difference pi is e to the power iota pi, right? This one e to the power iota pi. So this is iota pi, guys. Okay, e to the power iota pi, because e to the power iota pi value is -1. E to the power iota pi value is -1. Okay, so we can write this. So it means pi value is e to the power iota pi. So that means this means phase difference is pi. Okay, so phase difference is pi. So phase difference is pi. It means phase difference pi means here. So phase difference pi for half wave plate, right? So for this we have for this these equations we have, we can see the electromagnetic wave after passing through that optical element. We have got this value, and here we can see the we have seen the value of pi is pi, right? Value of pi is pi. So it means this is the phase difference is pi, right? It means it is half wave plate, guys. So the optical element is half wave plate. So which option is correct? Let me check. Half wave plate, that is option B is the correct, guys. Okay, option B is the correct. I hope you understood it, guys. Okay, option B. Okay. So this is the that part difference. So we have got phase difference, and by that, so you need to note down in this question. This you need to note down this. This is very important result which you need to note down. Okay, phase difference and part difference value for getting half wave plate or quarter wave plate. Okay, well, so this is the answer. This is e to the power theta. Okay, e to the power iota theta equal to this. Okay, so theta equal to this. Okay, guys, so this is the question. Next question we'll do. Just let me check. Next question. Next question is question number 4. Question number 4. Okay. Question number 4 is, in a young double slit experiment, in a young double slit, in a young double slit experiment, in young double slit experiment using light, using light, the apparatus, the apparatus the apparatus has two slits, apparatus has two slits of unequal width, unequal width, of unequal width, when only slit 1 is open, the maximum observed intensity, maximum observed intensity, maximum observed intensity, maximum observed intensity is I naught, is I naught. When both this when both the slits, okay, intensity is 4 I naught, guys. Okay, when slit first is open, the maximum observed intensity 4 I naught, 4 I naught. When only slit 2 is open, only slit 2 is open, slit 2 is open, the maximum observed intensity is I naught. When both the slit are open, both the slits are open, an interference pattern and interference pattern appears on the screen, appears on the screen, the ratio of the intensity of the ratio of the intensity of the principal maximum ratio of the intensity of principal maximum to that of to that of the nearest nearest minimum is. Okay, so gate question, guys, numerical type question. Okay, so this is the question which is given. So a young double slit experiment using light apparatus has two slits of unequal width. So their width is not equal. Okay, when slit 1 is open, the maximum observed intensity is 4 I naught. When only slit 2 is open, the maximum observed intensity is I naught. Okay, when both slits are open, an interference pattern appears on the screen. Okay, the ratio of the intensity of the principal maximum to that of nearest minimum is. Okay, very good question, and I already explained in interference pattern, right? In interference, so there's a formula for I max, maximum intensity upon minimum intensity, guys. Very simple question, formula based question. Okay, root I1 plus root I2 whole square upon root I1 minus root I2 whole square. Okay, so this is the ratio of maximum intensity to the minimum intensity. Okay, so I max upon I minimum is going to be, we'll put the value. Okay, so this is 4 I naught plus I naught, and these are root, guys. Okay, root. whole square upon root 4 I naught minus root I naught whole square, right? We'll solve it. So this is I naught will get cancelled. Okay, so root 4 I naught and this one, right? So this is going to be root 4 I naught root 4 this one is going to be 3 upon 2. So this is 5, my apologies. So 4 plus 5, right? So this is going to be this is going to be 4 plus 1 upon 4 minus 1, okay, whole square. So this value is going to be 5 square upon 3 square, right? So this is 25 by 9. Okay, just give me 1 minute, guys, 1 second. Okay, guys, so next, this is the question. Okay, we have done it. Now next question we are going to do. We made any mistake? Okay, so this is the answer, guys. Now we are going to solve the next question. Next question is question number 5. Okay, just let me check. Question number 5. Okay, this is also a good question, guys. A monochromatic a monochromatic a monochromatic plane wave in free space in free space in free space with electric field amplitude of 1 voltmeter is normally incident on a reflecting fully reflecting mirror fully reflecting mirror is, okay, into 10 to the power minus 12 PA, okay, Pascal. That is up to 2 decimal, up to 2 decimal. Up to 2 decimal place, okay. So this is a monochromatic plane wave in free space, with electric field amplitude is, okay, so monochromatic plane wave in free space with electric field amplitude of 1 voltmeter is normally incident on a fully reflecting mirror, okay, is okay, reflecting mirror is, okay. So you need to find out this pressure, Pascal, right? Reflecting mirror, the pressure of the pressure exerted on the mirror is, this is the pressure exerted on mirror, exerted on mirror, okay, P. Pressure exerted on mirror means P is, okay, P is, this is pressure exerted on mirror, okay. So P, this we need to find out, okay. So we know here, I'll tell you one thing, right, okay, this is important. So there is a formula, guys, okay, that is pressure exerted on the mirror is, so first you need to know that intensity, that is I is the, okay, first we'll solve this one, okay. So this you need to know, this is pressure exerted on mirror is 2I upon C, guys, okay, 2I upon C cos theta, okay. It is for if the mirror is completely reflecting, okay, if for complete reflection, okay, for complete reflection, and pressure exerted on the mirror, that is I upon C cos theta for complete absorption, okay, complete absorption, So these are very important formula, guys, you need to note down. If mirror is completely reflecting, then pressure exerted on the mirror is going to be 2I upon C cos phi, okay. And if it is completely if mirror absorbs the light completely, then in that case pressure is I upon C cos phi, okay. So this is in this question we can see the normally incident on a fully reflecting mirror, okay. So this mirror reflects it completely, right? So we need to find out pressure formula is 2I upon C cos phi, and here we can see this the monochromatic light normally incident on a fully reflecting mirror. Normally incident means cos phi value is 1, right? So in that case value of P is going to be 2 IC upon C, and this cos 0 is 1, right? 2 IC upon C for normal incidence cos C. So we'll put the value, right? And here we know, guys, I is equal to value of I, we know 1 upon epsilon 0 C E naught square. You need to note down, guys, very important formula we have studied in electrodynamics, okay. So I value is 1 upon 2 half E naught C epsilon 0 square, half E naught C half epsilon 0 C E naught square, okay. So we'll put the value, so it is going to be 2 into half epsilon c E naught square upon c. C will get cancelled. 2 will get cancelled. This is going to be epsilon 0 E naught square. Okay, or E naught square value is given, guys. E naught this is given. Okay, the amplitude of electric field 1 right. So this is going to be E naught. E naught value is 8.85 into 10 to the power 8.85 into 10 to the power minus 12. Okay, and this is into 1 square, right? So this value is going to be, pressure is going to be 8.85 into 10 to the power minus 12 10 to the power minus 12 pascal per meter. Okay, pascal per meter square, right? So answer is pascal per meter square, right? So this is this one. So this answer is 8.85 10 to the power 12. I hope, guys, you have understood it. Okay, well, okay. Okay, guys, so uh, I'm going to stop here, guys. Okay, so I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, guys. Okay, guys. Thank you. Bye.